I briefly talked about the language support for hash tables, or more generically, for the implementation of this idea of an associative array earlier, but I wanted to take a couple more minutes on this based on what we've just covered. So let's breeze through the more straightforward languages first. Over into Python standard documentation, Python has a dictionary type called dict, and that's what we use. It is, as you might imagine, a collection of key-value pairs. Very simple to use, but it's doing all this hash table work under the hood. Likewise, Ruby has a hash class, and if you notice, even the first opening paragraph here is all the terminology we've encountered in the last few minutes. A hash is a dictionary-like collection of unique keys and their values, also called associative arrays. Now, when we get over into C# and other .NET languages, we find multiple ways to support this. Some are basic options like the hash table class in system.collections, but there are also specialized versions optimized for when you can provide some constraints on this data structure. Here's what I mean by this. In system.collections.specialize, we actually have one called the string dictionary class, for example. This is a strongly typed collection. It will only hold string keys and string values rather than any object as a key and any object as a value. One of the benefits of this is whenever you get something out of this data structure, you know it'll be a strongly typed string. You won't have to check its type or cast it. Now, taking this idea over into the system.collections.generic, we'll find just generic dictionaries that we can create here, where you can create your own strongly typed version of this. You might provide a dictionary that was strongly typed to contain only string keys and only employee object values. And then you'd know that when you get a value out of this collection, it would already be a strongly typed employee object. And in .NET, you'll also find examples like sorted dictionary to keep this sorted by the key. There's quite a few options baked into the standard .NET framework, so if that is your area, I leave you to explore. Now over into Objective-C and the Apple world. Well, there is an NS_HashTable class, but despite the name, this is not what you would use if you wanted an associative array, and there are many Objective-C developers who's never touched this class. Instead, the workhorse implementation of this kind of data structure is the NS dictionary. Now, just as we saw that in Objective-C there are different classes for immutable and mutable versions of an array, it's the same for working with dictionaries. NS dictionary is immutable, meaning it's not resizable after it's been created, but there is also an NS mutable dictionary. Now, jumping over into Java, well, it probably won't come as a huge shocker that we also have multiple classes, including the hash table and the hash map. And the main difference between these two is that the hash table class includes processing to stay synchronized across multiple threads. That's a really good thing in multi-threaded applications if you have different threads accessing and changing this hash table, but it will add a performance cost. So if you're in a pure single-threaded environment, you'd get faster response with a hash map, which does not automatically synchronize. Now, just as a comment to the Java folks, hash table is one of the older collections. Now, you'll still see it used a lot because it's been around for so long. But what you'll find is hash table and hash map, these are implementing the map interface, and there's quite a lot of classes that do that. So take a look at some of the newer implementations of this idea, for example, like concurrent hash map, which is kind of a bit of a replacement for the older hash table. Okay, we've gone through a bunch of these, and that's probably more than enough. In a course like this, I cannot hope to be exhaustive about the options in every language, and particularly not, as you can see, when it comes to hash tables. This is intended to be enough to get you moving with the core implementation of this idea. Just stay aware that you may have other classes in the same general area, so take a look to see if you've got any extra functionality options that'll be useful in the situation you're working in. Now, we still have a few more data structures to cover before we can regroup and do a bit of a level set on some suggestions and best practices with all of these.